Hello friends, good morning, good afternoon. In this session, we are going to see normalization concept in RDBMS and what is the normalization, why it is important, and how to do that. So we will go through the that questions and one more thing. It is important for students as well as professionals. Correct. Means there is a how to design the database. At that time, normalization concept played a major role. Means suppose we have to design the database and there are multiple tables, we have to identify the entity, then what columns it have. So we will go through all these concepts and we will learn how to do that. Okay, then let's start. Normalization will help us in to reduce the data redundancy. Why it is important? To improve the data consistency, then simplified database maintenance, then next thing improved the query performance. Actually in the last, means when our session at the end, I will show you this slide again and I will explain you the proper example for these 3 points: data consistency, database maintenance, and query performance. Okay. And how to do that normalization? Yeah, there are different forms of normalization: first NF, second NF, third NF, bcnf, fourth NF, and fifth NF. But in the practical life, we are using the normalization till the third NF because it having the, means we are segregating the data up to the one level, and after that, means we are normalize the table into the again drill level, so it is to be more complex. Correct. So that's why we are segregating it at certain level and we are achieving the normalization. And there is a some denormalizations as well, means some example I have to show you, but which is at the end. In this session we are going to take one example, which is the school information management system. So it will help us, means what are the different entities of the school, and we have a denormalized data and we have to make it is a normal form. Correct. So let's take example. As I said, there are different forms, means first NF, second NF, third NF, bcnf, fourth NF, fifth NF. So first of all we will go through the first NF. What first NF is saying, means every column has unique value, atomic value, or we can call it as a single value. This is the example we have. Means first of all, this is the denormalized table. Correct. And here, this is the first year IT, second year IT, third year IT. Three student. First year Rahul is learning in the first year. Kiran in second year. Manish in third year. Correct. And they are having the subjects, means basics of computer, math, and physics. And Rahul got 60 marks in basics of computer. Same here, Kiran got C plus 70 marks in C plus plus. So this is the student wise mark. And one thing you can observe here, means first year IT having the three subjects and Rahul is learning in the first year IT. Correct. And this is the relation, means let's say first year there is a student is learning in class. Correct. First year IT and class having the different subjects. Correct. And subject having the marks. So this is the level, or we can say one continuous chain. And how to segregate this table into the, means how to achieve first normalization form. We have to normalize the student name, means there is a first name, middle name, and last name, and subject there is a row. Correct. Means basics of computer, math, and physics. and someone will write in a different order as well, math, physics and basics of computer. So it is also not a good choice. Means there is a insert, update and delete anomalies which will affect on the denormalized data. Means this is the sample of the denormalized data, correct? And how to achieve it should be in a normal form. Means first normal form, first of all we have to means segregate this data, correct? And how to do that? First of all, I am taking the example is, let's say, same here's example, and let's say I am making a subject one, subject 2, subject 3, correct? And marks, correct? And basics of computer, I am just writing the B, basics of computer. Then there is a math, and then there is a physics, and how much marks obtained. There is a 60, for 50 and 40. But let's say here there are only means there are only six subject or a nine subject, no problem. But let's say I have to take with means I have to take another example like a product, correct? And and in product there are suppose we buy uh, 70 products in the any means s- uh, grocery shop, correct? 70 products. So product 1, product 2, product 3, and after that there is a quantity and how much amount of them. So it is not the good choice to make the data in such a way, correct? So what we have to do in such a case, we have to apply the means row means a comma separated value into the multiple rows. I have the example is ready. um yes, so instead of this, correct? So this data means what it contains. There is a basics of computer, math, physics. Means we are separating the rows, correct? Means comma separated value into the multiple rows. And then 60, 40, here we can easily understand. Miss Rahul, it is Rahul is learning in the first year IT, and first year having the three subject, and whatever the marks he obtained, 60, 50 and 40. But yeah, every column has unique values, but it is not the satisfying the first normalization rule. So we have to again segregate it into the three columns. Means first normal form, sorry, first name, middle name and last name, correct? So yeah, I did it. And means here we can easily say, means this is the more appropriate data as compared to this data, correct? Okay, then we, and here if you observe, there is a first year IT, means this information is repeating. Yeah, this is the correct information for the first year. Rahul Gopal Sonone means basics of computer and 60 marks. Let's say there is a one more student and he is in a first year, and someone will write this is the data. Yeah, they are not actually, they written in a different format, and then I am putting the name as a Sumit, and yes, and he is basics of computer, basics of, yeah, they will write date information in such order, so it is also not the good, correct? Actually, uh, means they are, their meaning is one, means basics of computer, but they are written data in a different format. So it it should be on a data consistency, means it violate the data consistency. But actually we will take into the another level, means in second normal form we have to handle that. Here, this table is satisfied the first normalization form, correct? Means every column having the cell and it contains the single value. So it is in the first normal form. Then what is the second normal form? second normal form is saying it should be in the first normal form, and then each non-key columns be dependent on the primary key. First of all, primary key. Primary key, it means there is a column should means that particular, if we are making a one column as a primary key, then it should not allow null value and does not allow duplicate value. This is the meaning of the primary key. And next thing, non-key attribute, non-key columns and attributes is the one. And non-key column means, suppose let's say these are the columns and those are the non-key columns, correct? So yeah, here these are the non-key columns. So each non-key columns be dependent on the primary key, means each non-key column dependent on the primary key. It means each column should be directly related to the primary key, not on the other columns. Means there is a no any relation between the subject and last name, middle name, because that subject is belongs to the that particular student marks ID, uh, not on the other columns, correct? So we have to separate that. Actually I added here one more column, student marks ID, just for your identification. Means that particular table having the one key, and which should means there is a class name is dependent on that, because we are uh, here we are capturing the information about the student marks, correct? Means that particular Rahul is learning in the first year IT, and he got basics 60 marks in the basics of computer, correct? And so how to miss we are identifying with the id as a one, it is just for the sample. Yeah, but this is in the second normal form, no, because yeah, the uh, each non-key columns dependent on the primary key, means every columns should be dependent on the primary key, not on the other column. So we have to segregate the table into the multiple tables. Okay, how to do that? First of all, we have, this is the repetitive information. This is the class having the repetitive information, correct? So we have to make the master table for them. How to do that? First of all, I am creating one student table, and there is a student information we are collecting, correct? Means here you can see student information means Rahul, Gopal, Sonone, three times repeating at here. We are making only one, correct? And then Kiran Pawar. Then there is a Manish Kapoor. So we have to write in only at one place in student. It is very manageable. Means let's say there is a student ID. We can keep that particular student ID instead of three columns. Correct? We will get that information because we have to join this table with that student table. Then we will get the information about the complete student, means whole information about the student. Means we can add mobile number, then there is phone, uh, and there is a contact number, address, and all the things related to the student we can manage in one table. We can separate or segregate into the another tables, but time being you can understand, yeah, only we are capturing the student entity information in a one table. Okay, then next thing, here class is repeating, correct? Means first year IT, and someone will write f first year, correct? So this is not the good choice. What we have to do, we have to write, means keep the information in only one table. So I am creating the one table for the class. Correct. So class having the class ID as a 123, and first year ID means information is also not repeating, and we have to just write where wherever there is a first year ID, then we have to write it as a one. When there is a second year ID, means we, here is the primary key, class having the primary key, and that class ID is foreign key in this table, correct? Instead of, and we are removing the strings data. And one more thing, it miss actually this table is in the second normal form. How? Because each non-key column dependent on the primary key, means middle name easily saying, yeah, it is for the student, and it giving us the complete information, and it is dependent on the student ID. Means each non-key columns is dependent on the primary key, and it must sorry, it means each column should be directly related to the primary key, not on the other columns. Means middle name is dependent on the directly this, then last name dependent on the student ID, not on the other columns. Yeah, and same like here, means there is a class name dependent on the class ID, correct? And we are making it as a PK, primary key. Okay. And next thing, class is done, first name, middle name, last is done, then subject. So we have to create the one separate table for the subject. Okay, this is the subject table, means basics of computer, math, physics, and whenever there is a new entry come at here for basics of computer, then you have to write the just subject ID as a one. Means instead of that particular subject ID, we are making it as a one, so we can easily identify, yeah, one is belongs to that particular subject ID and it is a primary key, correct? Okay then, and then next thing, our table look like as here. There is a student marks ID, correct? I grab from here, and then next thing, student ID. Here is the student information. Instead of three columns, means instead of these three columns, I'm making it as a only one column as a student ID. Then class ID. Here there is a first year IT, second year IT, and third year IT. You can see here, okay, and three student, okay, and there is a subject, correct? Means from subject there is a basics of computer, math. So data out of, means we have a table before of this, and we make, sorry, I did the changes at here. Okay, means our previous form is this, means first normal form, and in the second normal form, means we created the some master tables, and there is a one student marks tables, means we can call it as a transaction table as well, no problem. And it contains the all the information about the marks of each student, and they are having the subject and there is a class, correct? And here we can easily say, yeah, subject is dependent on that particular, but subject is not dependent on the class, because this is the complete relation, this is the complete information in a one table. And here we achieved the second normal form here. Okay, subject is directly related to the student marks ID, and here is the primary key, and it is the foreign key and which is came from the student table. Class ID is the foreign key which is came from the class table. And then subject it is the, sorry, fk, yeah, which is from the subject table, got it? And there is a marks, correct? Means here let's say I have a this row, and three means student ID is 3, Manish. Then third one, class ID is in the TYIT, means third year IT. And then subject seventh is the OS, and he got 58 marks. And likewise, if we have 100 or a millions of records, we can easily manage that, correct? And it satisfied the second normal form. Then we have to segregate this data into the another level. Okay, how to do that? Let's see. Yeah, first no, third normal form, means third normal form is saying, yeah, it should be in the first normal form, then it should be in the second normal form. And then next thing, all non key columns are dependent on each other. It means each column should be directly related to the primary key, not on any other columns in the same table. And avoid the transitive dependency, A to B, B to C. Let's say here subject column, correct? And sorry, marks column, and marks is dependent on subject, means on in which subject he got the marks, yes, in first subject, correct? So and subject is dependent on the student as well as in, means student is belongs to the class, and student subject is also belongs to the student as well, because uh, that particular student got 60 marks in basic of computer, correct? So it is the dependency, and we have to remove that dependency, so that we have to make it in the third normal form. How to do that? I am copying the data from, yes, and then next thing, student marks data, and then next thing, student class, yeah, I have to say how I distributed, means how I segregate that data. Correct. We have, I think you are correct. Yeah, means actually here you can see easily. Uh, First of all, our input is this, correct? Student marks ID, right? And subject is marks is dependent on the subject, subject is dependent on the class and student. We have to remove that dependency, right? And what we have to do, there is a one class having the multiple subject, correct? And I have to show you one class and multiple subject, right? So what will be our design here? You can maintain class id, subject id, and then there is a class subject. This is the one table we can form, but it is the design of many to many relationship. Actually, here one class, many subject means one to many relation, correct? So our previous table was there is a subject table and it does not have any class. Means how to relate that particular class is belongs to which subject, correct? And here we are making the relationship between the class and subject, right? And we can have the another design. This is the class id and subject id into the another table, but this uh, means actually this relationship it is for the many to many relationship, and we have to make the relationship as a one to many or a many to one. Means if we say there is subject means multiple subject one class, many to one, and one class multiple subject one to many, both are the one, okay? And this relationship is the many to many, means one class having the multiple subject, let's say one, two, three. But you can make the reverse order as well, means there is a one subject means basics of computer for the third year IT. No, this is not the good choice na. That's why we have to make such a relationship. We have to apply the means we have to add the one column as a class ID into the subject table, correct? So it is the many to one or a one to many relationship. Okay, so I'm reviewing this. It is just for the means this information is just for the your knowledge, means how to build the relation as a many to many. Okay, means in the practical case, I have to show means I have to give another example like the one customer buying the multiple products, or mm, one product is buy by the multiple product customers, correct? So customer and product, so there is a many to many relationship. So in that case the this architecture is fit, or this design is suitable, okay? But here there is a class and subject, we have to create the one relation, and student and class we have to create the one table, means relation it means the table, okay? And there is a student id and class id, correct? Here I created the student id and class id, and in the previous week handled means there is a subject and class, means that particular subject belong to the class 1, means it is in the first year IT, then C++ there is a second year IT, Java third year IT, okay? So yeah, I in case in future I have to add the one subject as a cam, means computer architecture and maintenance, so it is for the second year. So we can easily make the entry in the second year, and we can add that particular subject to that particular student, and we can assign the marks to him. Got it? And right now we segregated that table, means it is here is the five columns and we make it in the four columns. How? Means this is the one, and class subject into the one table, correct? And student class into the one table, correct? Here information is repeating if you observe closely, 111, means this is the repetitive information. We have to remove that. What we have to do, we have to maintain the another table, means there is a student id and class id, and we are referring that student class id into the another table. Here student class id and subject class id, means that particular, here we can easily identify that particular one is nothing but the subject class id and basics of computer, correct, and first year id. Okay, and he got 60 marks. As per our final design, means here I say I copied same thing in the final design, means this is our the example, means denormalized form, and we segregated into the five tables. Student having the different information, then class, then there is a subject class, means that particular subject is belong to the which class, and then student class, means suppose that particular student is studying in which class. In the suppose let's say right now Rahul is in a first year IT, and in the next year Rahul will be in a second year IT, correct. So here there is a one, and the data should like as, means he is in, means he will be in a uh, second class, correct. And then after in the after 1 year, hmm, he will be in a third year IT, correct. So such like that we can maintain the data, and it should be a very simple, means improve the data consistency, uh, means everyone can make the entry as a, means when we are input the application, means application is the source to retrieve the means to getting the information from the front end side, correct. And in application, so we are just giving the drop down, correct, and they are selecting the first year, second year and third year, right. And there is a subjects, so uh, means uh, in background we are making the id, and in the front end we are showing as a basic of computer math, so that having the combo box, means or a drop down, so information is a consistency, means that improve the database consistency. Then simplified the database maintenance. Here we can uh, actually in this design we have challenges like the insert, update and delete, correct. But here no any problem. Why? Because let's say I have to insert the information about the first year, uh, or we can say there is a first year IT, there is a, I have to insert the information for any student. Yes, let's say Sumit, Anil, sorry, okay, Anil, Pagar, correct. So we can easily information that into the student table, and that particular student in which class, yeah, he is in a fourth student, and then there is a, he is in a first year IT, correct. So we have to make an entry at here, and he's learning obviously that particular class having the this subject, so we don't need to make the another entry at here because it is the master table, na? And class student class ID, yeah, student class ID, what is the student class ID? Yes, fourth one, fourth entry is we made, we have to make. And then here student class id 4, then there is a subject class id. Obviously I have these three exam, miss these three subjects, and yeah, let's say 80, 85, then 60, 62 and 74. Okay, so 4, 4 and let's say 10, 11. So likewise we can maintain the millions of record, and data is a very in a simple manner, means insert, update, delete very quickly. Instead of this, means uh, one will write mathematics, then physics, and then basics of computer, correct. So it is, misinformation is not accurate, data is not consistent, correct. So but this data is a perfect, means actually this data in a consistent manner, that's why. And we are simplified the database maintenance as well, and then improve the query performance, means insert, update, delete we can very do the very quickly in a fraction of second. Okay, and there are some normal forms as well. means bcnf. We discussed about the third nf, means actually, to be frank, in the in the practical example, or in a normal life, we are segregating the data till the third nf or the bcnf, because this is the so much granular level. Correct, means subject, means student marks id, student class id, we can join these two tables, means student class id we can join these, and from this to student, then from this class to this class. Correct. So we have to join the five tables. Correct. So we will get the complete information, right, in the form of, which is in the more accurate format. Correct. So I have to say, we, in normal life or in a practical manner, we can drill the information, or we can uh, go to the third NF or a BCNF. Correct. What is the BCNF? BCNF ensures that each non-key attribute is dependent on the candidate key. Means, let's say, each non-key attribute dependent only on the candidate key. Means non-key attribute, it means this is the non-key attribute and this is the key attribute, so which is dependent on the primary key. So we can call it as a BCNF format. Here is also student class id is not dependent on order, it is dependent on the student marks id. So such a relation we can call it as a, in a bcnf, right? And bcnf, that fourth normal form, it's saying bcnf that ensures table does not contain the multi-valued dependency. And fifth normal form, highest level of normalization, involves decomposing the table into the smaller tables to remove the data redundancy and improve the data integrity. And what we seen earlier means, actually here is no any information is repeating. Means student, actually student class id means it belongs to, we can drill into again, means student mass id and student class id into the another table, then student mass id, student class id into the another table, then again we have to make a join, but it is to be more complex. So best way we can leave that table as it is, and we have to decompose till the at one stage or one level, and after that the complexity will again more increase. That's why. And yeah, from exam perspective you can learn this, but actually, instead of routing, we have to understand this concept. Conceptually we have to understand it, means we decompose the table into the master table and transaction table, and again transaction table into the multiple transaction table. So this is the transaction table, this is the transaction table. Correct. And it is called as a master table because we are maintaining the some strings data. And one more thing at here, because here there is a no any string data, all the things are in a, in a miss id related data or a integer data or a big integer data, and it taking very small space to store the data instead of take storing the such a data. Got it. And here we have to make the n varchar, 500 or 1000 or 200. So instead of just we are making the that particular column, miss n varchar 50, that's it, and we have to refer that id into the transaction table. That's it. And logically we have to identify the entities first. And back to the, I'm back, RDBMS model. Let's say school information management system. We have to build the database diagram for them, then identify the different entities, means student, class, department, then faculty, subject. First of all, identify the entities and then build the relation in between them, means one to many, many to one, means one class, multiple student, one department, multiple class, then one class having the multiple faculties. One faculty is means sometime one faculty is teaching the multiple subjects as well. Correct. So we have to build the relationship, and these are the relationship formats, means one to one to many, many to one, and many to many. Correct. And the um, relationship means relationship. After that, there is a uh, yeah, database designing. Correct. So you need to understand first of all relationship in the tables. And suppose let's say you have to design the database, three things are very important. One is first of all identify the entities. Correct. Means if you have to design the database for hospital management system or a school information management system or a library management system, then first of all identify the entities. Means what are the entities are come into that particular model. Then uh, then there are the different types of models. Correct. Means let's say conceptual, then logical, and then physical. Means first of all we have to identify entities, then what is the relationship in between them, and then finally we have to build the database. Means physically we have to create, means who is the primary key, who is the foreign key, and based on that our means this model we can build the database. And these are the some relationship as well. So in actually in the my starting videos I created some videos on RDBMS, so you will get the complete information on that. Miss, these are the some 5 minutes or a 10 minutes videos. Uh, you go through it, so it will help you in, means it will help you in the some foundation knowledge. Means database diagram, then how to design the database model, then relationship and models. Okay. And next thing what I have to say, uh, yeah, conclusion. Okay. First of all, before going into the conclusion, uh, let's say there is a application, correct? And at the end, I will show you, means I will say you about the why these uh, uh, things are come into the picture, means normalization, denormalization. Okay. And we will go through the denormalization slide as well. And first of all, yeah, first here there is an application. On application there is a country, state, and city. Means let's say first of all you have to enter your name, then from which city you belongs to, then there is a state. When we are selecting the country, then India is select, then there are multiple state. Here there is a South Africa, then there is a Switzerland, Tanzania, correct? So we have to select the country. Then state will appear. After selecting the state, city will appear, correct? In that drop down. So normalized architecture will be like, means we have to create the one country table and it having the all the names of country. And then there is a state, and state having the state name at here, and then there is a country. Means it is the many to one relationship. Means I shown you in this example there is a student and class, sorry, subject and class. So many to one relationship or a one to many. So we have to follow um, such a design. Okay. And then one Maharashtra state having the multiple cities, correct? Pune, Nashik, Mumbai, Ahmednagar. So and let's say Sikandrabad. Five means Hyderabad. Hyderabad means which country? India. Correct. So this is the normalized architecture. And denormalized architecture, which is the very means which is different. And let's say here country related information, and then Maharashtra state, and then city. And if I'm selecting the city country at here, India, then all the state, but here we have to make the only distinct list, correct? And then state will appear at here, and then city is when I'm selecting the Maharashtra state, and then I will get five or six entries in the city. But yeah, it is the denormalized architecture and it is the normalized architecture. We can follow both. It is our choice, no any problem. But when to use which model, it is dependent on us. Whenever there is a OLTP database, at that time we have to follow normalized architecture. Means this architecture means from OLTP point of view, means we can insert, update, delete data very quickly. So normalized architecture should be a more flexible, means actually it is the more good as compared to the denormalized architecture. And there is a OLAP, online analytical processing, means it is the data warehouse point of view, and this architecture in OLAP, correct. And um, actually in OLAP, we are following this architecture. Why? We don't need to look up at another table, no need to make a join. That's why. And means here we are making the join country with state, state with city. So we have to means collect the data, and then we are means then we have to make some ETL process, and then we have to all means collect the data, and we have to make a one separate entity, and we have to um, dump the data into the such a table, correct. So means this is the OLAP architecture, but time being you forget about this denormalize architecture. And when I am coming to the SSAS, then I will means clearly explain you what is the denormalized architecture and how to means avoid the lookup. Means here is the means one lookup to the another, one state ID to the another, then we are making the join, and it will be a slow. And in data warehouse there is a millions of records, correct. And means from OLTP point of view, yeah, there is a not much huge data, but from OLAP point of view, data warehouse point of view, there is a 10 years or a 15 years of data, and how to manage that, correct. So uh, we will actually see all these things into the SSIS lectures. And but here you could observe, right now I am giving the session you about the first normal form, second normal form, third normal form. So you have to consider this architecture, correct? And from OLAP point of view, this architecture. But here is the data redundancy problem occur, correct? Means there is a India, means we are writing the information again and again, right? So this is the not the flexible design for OLAP, means OLTP point of view. From application point of view, it is not the good choice. You have to maintain, you can. I hope you understand the means this is the country, state, and city example, as well as school information management system example. And one more thing, we have to go through another slide, that is the denormalization. Okay, and yes, denormalization it means increase the complexity. Correct, means we are aggregating all these information, means country, state, and city in a one table, so that is the complexity is increased, correct. And decrease the read performance and increase the write performance. Why I am saying decrease the read performance? Because in one table we will get complete information, means like when India, multiple states, multiple cities, all the information is in a one table, so decrease the read performance and increase the write performance. Why it means increase the write performance? We are gathering the information from multiple tables from ETL point of view, means from source. We have to read the OLTP data, correct. And OLTP data, it means the data in the multiple tables. We have to make a join in between them. Then we have to dump into the one table only. So increase the write performance. But from data warehouse point of view, read is important. We are storing the large data, and it requires the read operation. Correct. Means data warehouse is nothing but the millions of record, 10 years data, 15 years of data, or 20 years of data. So we require the means read performance in that case, not the write. But OLTP point of view, write is important. From OLAP point of view, data warehouse point of view, read is important. And the fourth point is over normalization. Means actually, over normalization, it means we are segregating the tables into the multiple form. Means actually, suppose we seen there is a this table, right? Previously. Yeah, this is the table. So we segregated into the five tables. So too much normalized means, so that is the denormalization. But in from conclusion point of view, I will say normalization is important for OLTP means application point of view, and normalization and oh, sorry, my bad. Here OLAP means data warehouse, there is a denormalization. Okay, still you have any doubts about any OLAP, OLTP? Actually, I will cover OLAP or a data warehouse session soon in the SSAS session. So, but if you have any doubts related to the normalization, then you can ask me in the comment section. No any problem. Thank you very much for watching this video. If you like it, please share it and subscribe my channel. Thank you very much. Bye bye.